Hi, welcome to Mrs. Park's Algebra 1 class. This is Chapter 6, Lesson 6, Organizing Graphs Using Matrices. So why are we doing this? Here is a table that shows high school participation in various sports. As you can see here, there are different kind of data here depending on what kind of sport it is, if you're a girl or a boy, how much the schools participate, and the participation. So these data can be organized into two matrices with the figures for boys and girls. So matrix is just a matter of organizing your data, your numbers, in a form that organizes things in a nice little box. Okay, so organize data using matrices. A matrix is a rectangular arrangement of numbers in rows and columns enclosed in brackets. Each number in a matrix is called an element. A matrix is usually named using an uppercase letter. A matrix can be described by its dimensions, or the number of rows and columns in the matrix. A matrix with m rows and n columns is an m by n matrix read by m by n. So here you have matrix A, and it has 3 rows and 4 columns. So you state this matrix by saying the number of rows. There's 3 rows and 4 columns. So it's a 3 by 4. So you read it as matrix A is a 3 by 4. Okay, and if you want to identify each element, like for instance this -1 here, the element -1 is in row 2, column 1. So it's in the second row here, and then the first column. So there's 2 here, the element 2 is in row 3, it's in the third row, 1, 2, 3, and the fourth column, 1, 2, 3, 4. Okay. For instance, this element 3, it's in row 2, it's in the second row, and column is second column. So it's in row 2, column 2. Okay. Example, dimensions of a matrix. State the dimensions of each matrix, then identify the position of the circled element in each matrix. So here we have, let's use that. Okay. So here we have a matrix A, and this is how many rows? There's 3 rows and 2 columns. So this is a 3 by 2. Okay. And they want you to identify this element here, element 7. So again, which row is it in? It's in the first row and it's in the second column. Okay. So first row, second column. All right. Next one, matrix B. Okay. So this one has only 1 row. So 1 row and 4 columns. So it's a 1 by 4. Okay. And they want you to identify element 2. So again, it's in the first row and third column. Okay. All right, next. Okay, so our next one, it's your turn, numbers 1 and 2. State the dimensions of each matrix, then identify the position of the circled element in each matrix. So go ahead, do numbers 1 and 2 on a separate sheet of paper and come back when you are done. All right, welcome back. So we are now looking at real world example 2, organize data into a matrix. Swimming. So at a meet, 10 points were awarded for each first place finish, 8 points for each second place finish, and 5 points for each third place finish. For a matrix to organize each team's points, which school had the most first place finishes? So here's a list of the schools. Here's a list of different swim styles. So we organize this, and you have 10, 5, 8, 8, 5, 10, 8, 10, 5, 10, 8, 5 in a nice bracket here. And here's your matrix. Okay. Now, North High School earned 10 points in both the freestyle and the butterfly event, so they had the most first place finishes. All right, here's a quick study tip. Corresponding elements. Corresponding means that the element are in the exact same position in each matrix. Matrix operations. If two matrices have the same dimensions, they can be added together. You add matrices by adding the corresponding elements of the matrix. Okay. All right, so here's an example of how we can do that. All right, so we're adding the matrix A with B. So that means if you have the first row, first column, you're going to add with the same first row, first column. So if it says A plus B, we're going to add. So 12 plus negative 4 goes in the first column, which is 8. Okay. And then you're going to just go ahead and whatever is corresponding. So you have the first row, second column, first row, second column. Add those together, it becomes 6. Okay. Second row, first column. Second row, first column becomes negative 9 plus negative 3 becomes negative 12. You just put it in the exact same position, the corresponding position. You have second row, second column. Second row, second column. 15 plus negative 10 is 5. And you put in the same position, second row, second column. Okay. That goes the same for when you have B plus C. Okay. But in this case, okay, in this case, you only have here, this is a 2 by 2, and this is a 2 by 1. So there's no corresponding elements. So since they don't have the same dimensions, they do not have the same dimensions, it is not possible to add these two matrices. They have to have the same dimensions. Okay. So here's your turn numbers 3 and 4. Go ahead and try numbers 3 and 4 on your own and come back when you are done. All right, welcome back. So we're going to move on to subtracting matrices. And this is the exact same concept here with adding matrices. Oh, where did my slideshow go? Try that again. Huh. Okay. Well, we'll just have to deal with that. All right, subtracting. There's matrix A, B, and C. If the difference does not exist, write impossible. All right, B minus A. So here we have different matrices. This is a 1 by 3, and this is a 2 by 3. So it's not the same dimensions, so it is not possible. Okay. Well, that one was easy. Let's move on to B. A minus C. Here we have 2 by 3 and a 2 by 3. So yes, that's possible. Let's go ahead and do A minus 3. I mean A minus C. Huh. All right, we'll just have to deal with that. All right, so you have A minus C. So you have 4 minus 1 is 3. Okay. And you have, you can do it in any order if you like. 2 minus negative 3, negative 1. 8 minus 5 becomes 3. So bottom left, negative 17 minus negative 10, negative 7. Bottom middle, 10 minus 8, 2. Bottom right, 6 minus 7, negative 1. So here is your answer here, nice bracket. Okay, so it's your turn, numbers 5 and 6. Go ahead and try those and then come back when you're done. All right, You can multiply any matrix by a constant called a scalar. This operation is called scalar multiplication and is done by multiplying each element of the matrix by the scalar. Study tip: matrix operations. The order of operations for matrices is similar to that of real numbers. You should perform scalar multiplication before matrix addition and subtraction. Okay, so as we would with any other real numbers, you should multiply first before adding and subtracting. All right, so how does this work? When you are multiplying, so you have matrix A, and they're saying find 4A, so multiply everything by 4. So everything inside gets multiplied by 4. So 8, 2 times 4 is 8, negative 4 times 4, negative 16. So everything here, all the elements gets multiplied by the same number, 4. And that will be your answer in the bracket. Okay, so your turn, number 7 and 8. So all you're really doing here is multiplying everything in the A by negative 3. And for number 8, multiply everything in the B bracket matrix by 2. So multiply everything by 2 and rewrite your matrix. And come back when you're done. Okay, so that's the end of today's lesson. That's a nice and quick lesson there. So be ready with your homework when you come back to school tomorrow. All right, thanks for watching.